Data type. All the object we discussed before, like signal, variable, constants, are a type. Data type. It's a type of things. Then VHDL contain a wide range of the data types. Okay, and how to declare the data types? Very simple. The declaration look like this: keyword type, type name is type mark. What are the data type for this? VHDL is known. Okay, is shown by this tree diagram. Type having actually four: file type, access type, scalar type, composite type. Now, scalar type has a four elements: enumerate type, real type, integer type, physical types. Composite type also has two: array type and the record type. In this lecture, we are going to discuss the types of data we are going to deal when we are writing the VHDL programming. First, scalar types. Scalar type. It can hold at most one value at a time. That is the main specification of the scalar type. It can hold at most one value at a time. Now, in this scalar type, we have numerate type, real type, integer type, and physical type. We will see first the integer type, which is very much similar to the C or C++ or other language of programming, like a mathematical integer. VHDL does not specify the maximum range of integer, but it does specify the minimum range, which is given in this form. Now, strange, we will see the example for the integer type. Architecture by the name of test for the entity test is begin process with the sensitive list X, variable A, variable by the name A is an integer type, and variable B as an int type. Now this int type has been defined already into the entity. What is the int type? Okay. Now begin, if A has assigned as a value 1, it's okay, it's integer, it's okay. Line number 1 is okay. If A is defined or given the value assigned as a -1, then it is also okay because it is an integer. But if A is assigned 1.0, now there is a problem. 1.0 is a float type data, that is we call in VHDL as a real type data. It is not an integer. This is line give you error at the time of compilation of the program. End of the process, end of the test. Next, real type of scalar. A real type which we call as a float type in C plus or C are the used to declare the object that emulate the mathematical real numbers. Okay, and it has a standard package in a standard library is from 1 minus 1 10 raised to plus 13 to minus plus 1 10 raised to plus 13. Okay, the plus minus and e is having same meaning as mathematical terms. Now, architecture by the name of test for the entity test is signal, having a local signal by the name of A, type of real, begin. A has assigned, the signal has been assigned, since it is signal greater than or equal to will be used. Signal has been assigned 1.0. Since it is a real signal, it's okay. This line is okay. It's a good. But if you write only 1, No, it's an integer type then. The value is an integer. The A is not integer type. It's a real type. It will not accept the value 1. It will give the error in the program compilation time. If you assign a as a value of minus e raised to, that is 10 raised to 10, it's okay. If you assign 1.5 e raised to minus 20, it's still okay. But if you assign a as a 5.3 nanosecond, now 5.3 nanoseconds is the time type. It's not a real type. That means it may give you, it's not may, it will give you error at the time of compilation of the program. Now, third type of scalar is the enumerate type. Enumerate type is a very powerful tool for the abstract modeling. Now, designer can use the enumerate type to represent exactly the value required for the specific operations, which is very good. Now you can see one type. Now type by the name of flavor is having a value undefined 1 z 1 0 1 and z. This type contain 4 character literal value that each represent a unique state in a 4-state value. X is for unknown, undefined value, 0 is logic 0, 1 is logic 1, and Z is the tri-state open collector type. Okay, yeah, you can have another example of enumerate type is type by the name of color is red, yellow, blue, green, orange. Okay, you can use color and find if it is belong between this, then you can use that. Yes, for example, one more example for simple microprocessor look is type by the name of instruction having addition, subtraction, load A, load B, store A, store B, out A, and FR, X of R. The model of this type, let's begin. Package by the name of instruct is type name instruction is again the same add subtract load A load B store B out A XFR etc is sorry etc is not there. End of the package instruct, we will start use work instruct dot all entity by name of MP having a port of instruct as an input instruction. Now this instruction type is defined in a package. ओके जैसे इंटीजर होता है बिल्कुल इसी तरीके से यहाँ पे इंस्ट्रक्शन को इस्तेमाल किया गया है. इंस्ट्रक्शन इज ऑल्सो टाइप ऑफ डेटा एड्रेस इन ए इंटीजर फॉर्म डेटा in and out in an integer form. End of entity MP architecture start with the keyword architecture by the name of MP of entity MP defined as beforehand is begin process sensitive list enter which enter you wanted, which instruction actually you wanted. According to that, type local variable for the processor, type name by regd type is array type of 0 to 255. It's an integer type variable a and b. There are two variable of integer type. Again one array variable reg. It's a register type. This register type we already defined. sorry, register type is a we already defined in process. Register type, it should be array of 0 to 255 of integer. That means reg has a bit or array, you cannot say bit, it's an array of 0 to 255 of integer type. Begin process begin case. What is the instruction? What is instruct? Instruct may be add, subtract, load A, load B, store A, store B, out A, XFR. When load A, that is LDA, instruct is LDA, A, that is A is a variable, should assign the value of data. Data is in and out. That means you have to take input, load the accumulator, load when LDB load B, B should have the data. When instruct is add, A is the accumulator, should be equal to assign the value A plus, this is the plus, misprint has been done by the book, it should be a plus B. If instruct is B, sub B, A should assign A minus B, subtraction of the accumulator. When STA store register REG, which is a register type, which is nothing but the array of 0 to 255 of integer type, is equal to addr. Addr is the integer type. Put addr equal to A. Put the accumulator in a register array. Similarly, when STB store the B, REG, addr, assign the value B, put B in accumulator in a register array. If instruct is out A, data which is in out integer, we have defined into the entity out, assign the value of A, the output will come out XFR. If integer is XFR, A will assign the value of B. End of the case, end of the process, and end of the architecture MP. With this example, you can very easily identify what's going on. The second example they have given for the IMRIT type is the traffic light. Entity traffic light by the name of traffic light is having a port, sensor as an input standard logic, clock as an input standard logic, red as an output standard logic, green light as output standard logic, yellow light as output standard logic. End of entity traffic light. Architecture start with the keyword architecture having a name simple of entity traffic light, which we defined beforehand, is type T state IMRIT type is red, either it is red, green or yellow. Signal present state, next state. There are two signal. It is of T type, T state type. Now T state type, that is T state type IMRIT data type. It may be red, green or yellow. Beginning, process, sensitive list, present state and sensor. According to the present state, the case will decide whether it is green type, it is red, it is yellow. which signal line has to be 1 or which signal has to be set 0, it depends. End of the case, end of the process. Again, second process started for the clock. Beginning, wait until clock events occur and clock equal to present state, will assign the value of next state. End of the process for the clock. End of the architecture symbol. There we have shown you, we have thrown the two example for immediate data type. Now we come across the physical type. Now physical type is, you can say, it's a physical quantity such as distance, we can say current hai, time hai, and whatever the physical quantity we are going to use in a VHDL programming. The range start like this. For example, given type, name the type as a current, given the name to the type, having a range is range from 0 to some value. Units, nanoamperes, microamperes equal to 1000 nanoamperes, milliamperes is equal to 1000 microamperes, amperes is equal to 1000 milliamperes. End of the unit. We will see one example for the physical type so that you can have a very good look at what it means. Following is a example for the physical data type. Package by the name of example is type, name is a current, is ranging from 0 to some value, unit, and we have defined the same unit as we have discussed before. Ends of unit. Again we use type. Load factor is, now this is the immediate data type. Load factor is small, medium, big. End of the package. Use work dot example all entity by the name of delay calculated is having a port out current as a out current. Now you can say it is out, but in the type of current. Now where is current? Current is assigned or defined in a package. Load, it is an input type in load factor. As before we write integer type, real type. Now we are doing it here, or we can say we are programmer are writing the type. Load factor. Load factor is immediate data type, small, medium, or big. Delay out type, physical quantity, time. Here we are using an example for the physical type. Here, where one is the physical quantity we are using is a time. End of entity, delay cal. Architecture, keyword architecture, start with the keyword architecture. Name the architecture delay cal. Of entity delay cal is begin. Delay, its output time. Delay will assign the value of 10 nanosecond when the load is small, or 20 nanosecond when the load is medium, or 30 nanosecond when the load is big, else 10 nanosecond. Output current is a out current type, will assign the value of 100 microampere when the load is small, will assign 1 milliampere when the load is medium, will assign 10 milliampere when the load is big, will assign 100 microampere if three of these conditions are not true. End of the architecture entity. Here we use the physical type, that is the time. Time, the variable comes with the name of delay. Out time, to show you the physical data type. Next is the composite data type, and we will start that composite data type. So basically, as you remember the tree diagram, where composite data type having two subtypes, that is array type and the record type. Here we are going to talk about the array type. Array is a very big question. It's a two-dimensional view of things in C++ and C and other programming language. It's very useful for to solve the matrices, where you can say it may be a three-dimensional, two-dimensional, and the same approach has been used in VHDL. Now, here one example of array type. Type, give the name of array as a data bus. Is array type having the range from 0 to 31 of a bit type? That means data bus is of a bit type having 0 to 0 to 31. That means 32 bits. It's an array of 32 bits. Okay, we will see one example for the as a program. Package by the name of array example is type data bus is array of 0 to 31 of bit type. Type again small bus is of array of 0 to 7 of bit type. End of package by the name of array example. Use work.array example.all. Entity start with the keyword entity. Give the name to the entity as extract. Is having a port data import, but in the type of data bus, which has been defined in a package array. Then again port with the start. Start is an integer type. Data out is a out small bus data type. End of the entity extract. Architecture start with the keyword architecture. Give the name to the architecture as a test. Of entity extract is begin. Process with the sensitive list of data and start. That means any event on the data or start, the process will start its work. Begin. For loop for I in 0 to 1, sorry 0 to 7. Loop start. Data out is the output small bus. Will assign the value of data in bracket I plus as start value. End of the loop, end of the process, end of the architecture test. Entity takes 32-bit array type element as a port. One more example of array has been shown over here. It's a long way. It's a two-dimensional example of array. Library IEEE use IEEE.standardlogic1164.all. Package by the name of memory is constant by the name of width having integer value 3. Again second constant by the name of minimum size integer value 7. Data type data out is array type of 2 to width. Width is having a value fixed value 3. That means 2 to 3 of standard logic. Type mem, that is memory data, is array again 2 to mem size. Mem size 7. That means 0 to 7. Array of 0 to 7 of data out type. Now data out type we have defined data out type. Okay. That means there will be 7 rows and each rows has 4 bits. 0 to 3, that means 0, 1, 2, 3, 4. And 0 to 7 means, sorry, 0, 7 rows nahi hai, I guess. 8 rows, 0 to 7. That means 0, 1, 2, 3, 4, 5, 6, 7. 8 rows, and every row will have 4 bits of standard logic. End of the memory package. Library IEEE use IEEE dot standard logic dot all use work memory dot all entity start with the keyword entity, name the entity by room, is having a port adder in integer type, data out type, data out type is defined in a memory package, CS in a standard logic, end of the entity ROM architecture by the name of basic of entity ROM is start in a declaration part of the architecture. We declare some constant z state, data out type. Data out matlab you it is defined in a package of array 0 to the width is 3, 0, 1, 2, 3, that assign the value of z 4 times, z for tri-state levels of buffer, z again constant x state. It is also a data out type. Again it's an array of 0 to width is 3, x 4 times 0, 1, 2, 3, 4 bit, x4 undefined, then again constant by the name of ROM data. It's a meme data type. That means what we have already discussed, it has array 0 to minimum size, that is 0 to 7 size of data out. Every row has 4 bit and total rows are 8. You can see assignment of the values dot colon equal to first row, second row, third row, fourth row, fifth row, sixth row, seventh row and eighth row. And every row has total 4 bits. That means it's a matrix of 8 to 4. Begin of the architecture and the process, whatever we are going to do with this data. Okay, this has been a second example of array. Now we will see the record data type. A record type of group object, sorry, a record type group object of many types together as a single object. For example, if you say type OP type is, or that is operational type is add, subtract, multiply, division or jump. So these are the one of type of a instruction. So this what we call as a record type of declaration of data type. One example we will see for this. process with sensitive is X, variable instruct in instruction type, variable source and destination in integer type, variable of operator in op type. Have you already seen? We have defined the op type. Begin, source, assign the value since it's a variable, the colon equal to instruct cr, data destination, assign the value instruct cr. These are okay. But if you are writing source to a opcode, it's an error line. One more example they have shown you over here. Type word is array 0 to 3, that is 4-bit of standard logic. Type keyword array is also 0 to 15, that is 16-bit of word. That means 16 row of 4-bit. Word is 4-bit and it is also an array of 0 to 15. So you can imagine, as before we have already done, 16 row of 4-bit. Type adder type is record, that means it's a record type having source as an integer, key as an integer, end of the record. Now type data package type is also record, address adder type, data word type, we already defined word type and adder type, checksum integer type, parity boolean type, end of the record. We will stop the video and remaining two types we will continue in the next video.